Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating project. Data scraping League of Legends replays the hard way. For fun! It's a wild ride.
Wow, sounds intense. What's the core challenge here? Why is this so difficult?
The main hurdle is accessing detailed, moment-to-moment gameplay data. Riot's public APIs only offer aggregated stats, total kills, gold, etc., not the granular data needed for advanced analysis. Think player positions, ability usage timings, damage calculations at millisecond precision. That's what makes this project so unique.
So, existing datasets are lacking in granularity and precision? What are the implications of that?
Exactly. It limits the types of models you can build. You can create basic win prediction models, sure, but forget about sophisticated reinforcement learning agents like those used in StarCraft 2 or Dota 2. Those require high-fidelity data, which is currently unavailable for League of Legends.
I see. So, this project aims to build that high-fidelity dataset. How's it done?
By reverse engineering the game engine and replay format, the author directly decrypts and processes the game's internal replay files, the ROFL files. It's a complex process involving emulation and decryption.
Emulation? You mean like running a virtual machine?
Not exactly. It uses an emulator to run specific parts of the League of Legends binary, without running the whole game. This helps in debugging and understanding the encrypted packets within the replay files. Think of it as a highly targeted debugger.
Okay, got it. And the decryption? Is it simple XOR or something more sophisticated?
Oh, it's way more sophisticated than simple XOR. It involves a 255-byte lookup table, combined with a series of arithmetic operations. It's a clever obfuscation technique, making it challenging to reverse engineer directly. The author even mentions that the encryption methods change frequently with game updates.
That sounds incredibly complex. So how did the author overcome this?
Instead of fully reverse engineering the decryption, the author uses a clever trick. They intercept key values directly from CPU registers using trampoline hooks. This allows them to extract the necessary data without needing to fully understand the decryption algorithm. It's a pragmatic approach, focusing on results over complete understanding.
That's a brilliant workaround. But doesn't that make the system fragile to game updates?
Yes, it does. The hooks need to be updated whenever Riot changes the game's internal structures. The author acknowledges this limitation. There's also an alternative approach mentioned in the article, which involves running the game client in replay mode and sampling the game state at fixed intervals. This is simpler to maintain but less precise.
So a trade-off between robustness and precision. What about performance? How fast is this data scraping process?
Surprisingly fast. The author initially used the Unicorn emulator, which was slow, but then rewrote it in Rust, creating what they call an exception emulator. This native implementation processes a 15-minute replay in just 3 seconds. A significant improvement over the initial approach.
3 seconds? Woo! That's amazing! What are some of the other interesting aspects of this project?
The article also discusses several potential optimizations that Riot could implement in their game engine and replay format to reduce data size and improve efficiency. Things like removing redundant packets, using variable-length integer encoding, and employing multi-threading for packet processing. It's a fascinating blend of reverse engineering, data analysis, and system optimization.
It really is. This project highlights the challenges and ingenuity involved in extracting data from complex, closed-source systems. It's a testament to the power of reverse engineering and creative problem-solving.
Absolutely. And that's a wrap for today's Tech Bytes and News. Thanks for tuning in, and we'll see you next time with more exciting tech discussions. Goodbye.
Bye-bye.